So let's present right now a new extension of the partial equilibrium model, which is different from the previous one because we introduce a world market. So let's study the wheat market. We are still interested by the relation between production and consumption. So here between farmers and bakers who make bread. So we can have a direct relationship between local producers and local consumers, but we can also imagine international trade, so exports and imports. And so this is why we consider right now the world markets. Okay, so let's now introduce a world market. So we study the wheat market. And so it raises several questions. First, how do we model end countries or regions? So we will have, of course, the biggest producers of wheat in the world. We will have also the African continent because we are interested in this continent. And so we have to adopt a synthetic way of modeling these end countries or regions. Another questions, how do we model a world market and how do we model the linkage between the world market and local markets? So we start with a set, and this set is a set called R, and it is composed of n countries or regions. So it means that we may have countries like France, United States, China, and other countries, and we can have region. So here, for example, we will consider the African continent. It means that we gather all African countries in a single region. And of course, we will have also the rest of the world, which will be composed of all countries not included in the previous list. And so each country or region has a local demand and a local supply. And so with this set, it's very powerful because we can right now have n demand with only one notation, which is xdr, and n supply called xsr. So we've got n supplies, n demands. We also have n local prices. So this is prices within each country. And we have also 2 multiplied by n elasticities. Why? Because we have supply and demand. So 2 functions and 1 elasticity for each function. I remind you that we keep the isoelastic form of these functions. And we will have also 1 size parameter for each function. So here we have 2 times n size parameters. So let's now present how we model the world market. In fact, we simply say that the world market is the place where the world price is determined. So you remember that this is something that I mentioned earlier in another lesson, that we can have determinations of price by an equality between supply and demand. So this is exactly what we do here, because in fact we say that the world price is determined by the equality between world supply and world demand. Okay? And how do we determine world supply and world demand? But this is very simple because it's world supply is the sum of local supply and world demand is the sum of local demands. So let's present right now the way we model the linkage between local markets and the world market. We start with a remark. There is only one good in this model, but there are n plus 1 prices of this good. So here, for example, we will consider an example with 14 regions, and so it means that we have 15 prices, the world price, and of course n local prices corresponding to each region or country. So what is the linkage between, in fact, local prices and the world price? So if there is a difference, it may come from transportation costs. So until now, we do not suppose any transportation costs. So if there is a difference between local price and world price, it may come from a tax. So if there is no tax, the local price is equal to the world price. And if there is an import tax, for example, we start with this example, in fact, the local price is above the world price, and the type of relations is P in country R is equal to the world price, PE, times 1 plus the tariff imposed by country R on its imports. So let's present very quickly the impact of an import tax, very quickly, because this is something that we have already presented. So if we have the no tax, it means that the local price P is equal to the world price PE, and so it means that there is a certain level of local production corresponding to this local price and a certain level of local consumption. If there is an import tax which is implemented on imports in this country, so it means that the local price is going to augment at a level of P prime, which is equal to PE times 1 plus T. And so the effect will be to raise local production and to decrease local demand. Let us now explain what is the impact of an export tax. So we start with different situations because initially the world price is above the intersections of supply and demand, that is to say above the autarky price. And so at initial price, that is to say without any export tax, the domestic price is aligned on the world price. P is equal to PE, and at this level of price, the supply is much greater than the local demand, and so the difference is exported to the world market. What happens with an export tax? Well, initially without export tax, local producers are indifferent between selling on the local market and exporting, but right now with a taxation, it's different because right now exports are taxed. So it means that with a world price of PE, the local price has to change because it has to decrease, because in fact at P is equal to PE, producers prefer selling on the local market because local sales are not taxed while exports are taxed, and so augmentations of local sale decrease the level of the local price until P prime is equal to PE divided by 1 plus T. So for example, if you've got a world price of 100 and a tax of 30%, the local price is equal to 100 over 1.3, which is something like 77. So the local price has to decrease to around 77 in order to be sure that right now at this level of price, local producers are indifferent between selling on the local market and exporting. So what is the impact of an export tax? It decreases local price, it increases local demand, and it decreases local supply. Let us now present the linkage between the world market and local markets. So it's very simple. It's a unique relation, of course, applied to each country or region. So it's this equation, the local price, P in R, is equal to the world price, PE, times 1 plus the import tariffs implemented by R, divided by 1 plus the export tax applied by R. And so this is a very general relation. Why? Because if you have free trade, then TR is equal to 0, TX is equal to 0, and so the local price is equal to the world price. If there is an import tariff, there is no export tax because you do not have any exports. And so you have TR, which is positive, TX, which is equal to 0, and so the local price is above the world price. If you've got an export tax, you don't have an import tax because there is no imports. And so you have TR, which is equal to 0, TX, which is positive, and so the local price is under the world price. And so it's a very general relation. So right now, let us present the list of countries, and then we will continue with the data that you need to feed this partial equilibrium model. So here are the countries and regions that we consider in this study of the wheat market. So let's notice that we've got an average for 2015, 2016, 2017. Why? Because it's always risky to take data from a single year, because maybe this year is not representative of a long-term trend. So we've got here 14 countries or region. We have the 12 biggest producers of wheat on the world market: China, India, Russia, United States of America, France, Canada, Ukraine, Australia, Pakistan, Germany, Turkey, United Kingdom. Then we have the African continent, which is gathered within a single region. And then we have the rest of the world, where we have all other producers of wheat. So I decided to choose the 12 biggest producers in the world. You can, of course, consider that it's not good. We have also to consider the biggest consumers on the wheat market. Of course, you have to justify your selection of countries. So here Africa is a single region, because African countries are not very efficient in the productions of wheat, and so they are relatively small producers, and the rest of the world is summarized in a single region. So now you need some data to fit the model for initial values of variables in particular, but also for values of parameters or exogenous variables, which are import tariffs and export taxes. So you've got here the 12 biggest producers, and you have the African continent. And you have data on local consumption of wheat and local supply of wheat. So local consumption is XD and local supply is XS. Then you've got data of import tariffs, T, and data of export taxes, TX. So in fact, XD and XS come from FAO stat. T comes from the trains database from the UNTAD, and then TX. So I have searched for data on export taxes. In particular, IFPRI had recently collected some data on export taxes, and I didn't notice any taxations of exports of wheat in 2016. So all the taxes are equal to 0. You also need some elasticities. Because I remind you that we've got functional forms for the supply and demand functions, which are of isoelastic forms. So here are the elasticities of supply functions and demand functions. So it comes from a review of literature and some extrapolation from other countries or from other commodities. Finally, you need an initial world price of wheat. In US dollar per ton, it will be 190. You need a world supply, so it is around 757 million tons. Then you need an import duty applied by the rest of the world. So I calculated an average duty for the rest of the world, and it is 5.21%. An export tax by the rest of the world, it will be 0. So the two scenarios I would like you to study is first an impact of a total liberalizations of the sector, and then another one which is independent from the first one, so please do not add this second one to the first one. So the second scenario is an export tax applied by Russia and Ukraine, and this export tax is 20%. Of course, I would like you to make some comments in order for you to make some economic analysis. I would like to make a few remarks about this program. First, the use of the instruction sets. So it's very powerful. In fact, if you look at the .lst file, you will notice that there are only 4 blocks of equation. But thanks to the instruction sets, we have in fact 43 equations. So it means that with the instruction set, we can write very powerful programs with only a few equations. Of course, there are potential extensions. So this is my second remark. We can introduce differentiated goods. We can, of course, make an extension to any number of countries. So, for example, 20 countries, 30 countries, and it is, of course, we can do that thanks to the sets instruction. We can also include other policy instruments like a consumption tax or a production subsidy. And we can also introduce some transportation costs. Even if in this configuration, I mean, transportation costs would be a little weird because, in fact, we have, transportations from the world market to a country or from a country to the world market. So it's better if we want to have some transportation costs to introduce a different structure of the program. So we can change the program, introduce bilateral trading costs, but also the possibility for each producers to sell everywhere their products, locally, but also in any place. And of course for consumers to buy everywhere what they want to buy. So it means that we would have bilateral relations of exports and imports, and this is what we call a spatial model.